All right, welcome back. Let's see if we can't finish out this greedy match. So this right here will match greedily, and we've already argued that I'm going to need to keep track of where we were at, right? So I'm going to use the stack in the context to just push that out. But now let's override match next, and I find this one to be perhaps the most interesting one. In fact, for me, when I was writing this, I found greedy to actually be more complicated than lazy, and I kind of expected that lazy would be the weirdest one because when you backtrack it tries to consume more, but I don't know, maybe I am weird. This one I thought was harder. So first things first, let's figure out where we were at when we left. So let's go to the context, stack, pop, right? And get back that index. So this is now we've restored the state back because I'm being backtracked into, and I've got an option here to figure out where we left off. Now this actually splits into two cases, right? So either the index is 0 or it's not. So if the index is 0, what does that mean? That means that when we matched the base number of times, let's say 3, and then we said, okay, that worked, and then we say match greedily from 0, and it went in here and it immediately failed, right? Then we pushed 0, which means that this guy never actually matched. So at this point, I have no other options. I have no optional ones here. I don't have my 4 more A's. I actually have to backtrack into the base class level, right? So I need to go back into repeat and see if it can try options through the first 3 iterations of the match item. And if it does, then great, then we'll just match greedily again. But if it doesn't, then we've actually failed. So in the case where we've now got, in the case where the index is 0, then if not base.match next of context, then now we are out of luck, right? Completely. So I hope that makes sense. Otherwise, we've actually matched. So if this doesn't fail, then it's gone through these first 3 iterations of the token, and it did find some other version of the match. And now we're back in our starting state as though we were matching from 0 again. So then in this case, I will just return match greedily on the context, right? I'll just match forward from 0 again because that's where we're at. Okay, so one thing I did notice is I want to flip back here, and this should not be visible. Okay, so what happens if the index isn't 0? Then that means we did optionally match a token. So that token itself, and remember, I always think of match char, that token has to be at least match nexted once so that if it fails, it will restore the matching context state back to where it was, right? So in this context, we've actually matched something correctly. So I can say this first. So if the match item can do something else, right? If it itself has an alternative, then we can just match greedily from this index, right? We can match forward from here. So then return match greedily context index, and we should be good to go. Okay, so one thing that's a little bit non-obvious is it's a little weird, and it even stumbled me here for a second as I was looking at my notes. But why is that literally index and not index plus plus? So, or plus plus index, right? So if, let's say index was 1, for example, so the number that's actually stored there, right? Recall, if I look at what happens objectively the first time through, if I do in fact match something once, then I increment the index, and let's say that was the only time, and then I push the number 1 onto the stack, right? Which means I've actually completely matched one optional iteration. If I come back over here and I get backtracked into and I pop this off the stack, this is a 1, so we skip this case. If that particular iteration of the item has an alternative, then I have in fact matched once still, right? And so that is my current state. So when I go in here and match greedily, then if 1 is less than max and I match again, then the index will become 2, and that would be 2 complete matches. Let's say that succeeds. The next one is either fails for either condition, then I push 2 onto the stack. And that is in fact the correct behavior. It feels a little funny, but because of what this number represents, that's just correct. So anyway, that's something as an aside. So, okay, so what do we have? What cases have we covered? So we've been backtracked into, and we had no other options, in which case we had to go back into like the must-have repetition. If that doesn't work, we fail. Otherwise, if that succeeds, then we just match forward greedily again. That sounds good, right? If we had options, then we need to go first try backtracking the token, right, for this, whatever this optional iteration is, index. And if that worked out, then we will match greedily from here forward, right? We'll just keep on trying to match. If that doesn't work, then what are the options? So the other case is the following. So if this doesn't work, then I will say context.stack.push -- index, and then I'll just return true. In fact, I don't even need this else block, I guess. Right? And this behavior here is truly the behavior of greedy matching. So I'm going to go in here and I'm going to consume as many as possible until I can't do it or I hit the maximum, and then I'll just make a note of how many I've got. If I get backtracked into and I have options left, either this guy's going to work again, and then in which case I'll just greedily consume, or if he doesn't, then I'll say, well, I guess we just can't match it that many times, but we've already matched it, you know, some number of times, because I'm not in this case, so I'll just push the one less time back onto the stack and return true, because I've so far been successful. Now, oh shoot, what was I going to say? I thought of something. Oh, I was thinking, so okay, so again, if you think of match item as being match char, it's important to note that the state of the context is correct now, because I've come in, let's say, and if I'm back in this place, sorry, if I get to this code, right, I've matched something an optional time, I've gone in here and I've said, oh, can you match something again? And it says no. So again, I assume this is like match char or something. This match next will have failed, which means that this token, whatever match item is, will have restored the context state appropriately, and therefore it's safe for me to just push this right on the stack without having to worry about the offset or anything, because I'm already in the correct state. Okay, so I hope that made sense. Now let's come over here and let's try it, man. Let's do something. So let's say public static void match greedy test1 var context. I always do that. Var context equals new context, and we will say, well, let's do our examples, a, something like that. And we'll say var char a equals new char of a. Oh, yeah, that's going to be a problem. All right, so let's take this and rename it back to match char, I guess. Don't know what else to do. Call it match char. Everybody saves. You go away. Come back over here. Now this is a match char unambiguously. All right, sorry about that. And then I will create var, I'll just call it item. equals new greedy, and it's greedily going to be the single character A, and it will match between 2 and 4 times greedily. Okay. Exec test on this item in this context. All right. Should really move that. That's okay. Okay, so let's see what happens. All right. So recall, we're matching all of these guys. So we try. In fact, I should really just have it over here. I like to write this in here sometimes. So I'm matching A, 2, 4, right? Okay, so I issue a match success. I'm sorry, issue a match, it runs successfully. We consume 1, 2, 3, 4 A's, and now the pointer is sitting at 5, and that's fine, which is index 4. The stack contains 2, which means that the greedy token has said I've matched 2 tokens optionally, and notice that that is the difference between 4 and 2. And then we continue issuing a match next on it. If we issue match next, it succeeds, but you can see here, and we know what should be happening is it succeeds by releasing one of its matches that it doesn't have to have, right? So it moves back to 3, and it has successfully stored 1 optionally. If we issue a match next again, we succeed, and it succeeds by backtracking and throwing away one of the optional matches. Now we are at the minimum number of matches, but that's still okay, because the minimum is the minimum. That's acceptable. Then we issue a match next, and now we're getting into the stage where, gosh, we have to match at least twice, and that completely fails like it should, and therefore notice the stack has been restored, pointer's restored, and everything looks good. Okay, so I'm going to end this video here since that seems to function. And next video I think we'll just throw some more interesting tests together to play with the alternation and the greedy matching to see that it's really doing kind of what we are expecting it's doing, and we'll go from there.